topic for today is centroids. So, as usual, let's have an introduction. So, previously, we discussed the concepts of equilibrium and applied it to the analysis of structures such as trusses and frames. Now, another topic related to equilibrium is center of gravity and centroid. So these two are often interchanged with each other. However, even though they consist of a common concept, center of gravity and centroids are two terms that differ based on the concept in which it is used and the object it is used in regards to. So first, let's focus on center of gravity. Center of gravity is the point through which the action line of the weight always passes. Also, center of gravity is the point wherein the mass of the object is concentrated. So because of this, we also call center of gravity as center of mass. Okay, and then centroid, on the other hand, is the geometric center of an object. It is used to denote the center of a body with uniform density. So in general, center of gravity pertains to a physical property relating to weight, while centroid pertains to a geometric property. Okay, so that's the main difference. Now, when your object has uniform density or is homogeneous, then its centroid is the same as the center of gravity. For our examples, almost all of them are homogeneous. Therefore, when we say center of gravity, that means the same point as centroid. Okay? So although their definitions are different, because of this condition, they can be interchanged or they are interchanged. Okay? So next. So why do we need to know center of gravity, right? Well, if we know the center of gravity of an object, we can do the following. First, we can determine the maximum angle that an object can be tilted before it topples over. So this is beneficial because it helps us create interesting shapes in our structures for architecture and engineering. Another thing we can do is we can approximate an object to a point while keeping its inertial properties. So inertial properties are the characteristics that make something resistant to change or motion. Now, this is beneficial because even though when you have a body, we can consider it as a point instead, and because of this, we can greatly simplify problems of mechanics in which the motion of an oddly shaped object and other complicated systems need to be described. So instead of solving for an odd shape, we're just solving for a point. Okay, so that's another benefit of knowing the center of gravity. The third thing is that we can know if forces will cause linear or rotational motion. So if a rigid body is pushed at its center of mass or center of gravity, then the object would just move linearly. It would not rotate about any axis regardless of its shape, as long as your force is along its axis or center of gravity. However, if an unbalanced force is exerted at a point other than the center of mass or center of gravity, then the object will rotate. Okay, so that tells us if an object will move linearly or rotational. And then the fourth thing is that we can produce uniform stress distribution. So this is important because loads must be placed so that the line of action of the resultant coincides with the centroid of the cross-section of the member. If you had this topic in statics, right? Remember, whenever you have a normal force, there's a way, or eccentric force in this case. Eccentric force are forces not on the axis or acting on the axis of your member. Whenever we have an eccentric force, it's beneficial to move it to its axis. When you do that, you create a normal force or an axial force and a moment. Okay, so if you remember that from your statics. And then lastly, determine the location of the neutral axis of a member. So neutral axis is a term you're gonna hear a lot of when you get to your higher mechanics, or rather design subjects if you have any. So the neutral axis passes through the centroid of the cross-section of the beam, and it is important in computing for bending stresses. Okay? So recall, the only stress that we're concerned with was direct stresses. Bending stress is an example of indirect stress. And again, you'll talk about that more in your other subjects. Okay, so let's have an example. So we have this leaning tower of Pisa, right? It's at an angle and yet it's standing. Now, why is that? It's because we have this concept that any object or structure that stands on its base will keep standing or is stable, meaning it, even though it rotates, it's going to go back to its original state until the line drawn from its center of gravity to the ground falls within its base. So for example, we have these structures here. So at situation 1, this is the center of gravity denoted by the red dot of the object. Draw a straight line. As long as the straight line falls within the base, it's gonna stand. So again, here in case 2, draw a line. It's still within the base, that's why it's standing. And then here on case 3, it's barely within the line, but it's still standing. And then here at case 4, it's now outside, or your line is now outside the base. So in this case, this will fall. Now let's check for the leaning power of Pisa. Approximately, this is the center or center of gravity of your structure. Draw a straight line. As you can see, it's still within the base. Okay, so that means it's still gonna be stable or it's still standing. Now, these are other applications of the benefits of knowing the center of gravity. As you can see, we can create interesting structures and design that seems to defy gravity because we know how to work with it. Okay, next. Here's another application of knowing the center of gravity in martial arts. Specifically, this is Judo. So looking here, the black belt can easily throw the white belt because the black belt uses concepts relating to center of gravity. So to illustrate, we have this figure here at the bottom. So first, so the blue skeleton is your opponent. As you can see, it is still stable because the center of gravity is still within the base of this skeleton. Okay, so the goal of Judo is to successfully throw your opponent. So to throw your opponent, they must make sure it's not stable. Okay, to make it unstable, you have to make sure this line is not within the base anymore. And to do that, you can pull your opponent. So as you can see, the green skeleton pulls, and now this line is outside the base. So this person or this skeleton is now unstable. Another thing we can use relating to center of gravity is, remember, when we have a force not acting at its center of gravity, that causes rotation. So for example, here, there's a force pushing at this side, which is below your center of gravity. So the tendency of your body is to rotate. So in Judo, first you break the balance and then you exert force to rotate about the center of gravity, and that is when you successfully execute a throw. And so these are just some of the applications of center of gravity. Next, let's have some equations. Okay, so first, center of gravity of a flat plate. So the analytical location of the center of gravity is simply a variation of the principle of moments, and we'll get this answer. So for example, you have this flat plate with uniform thickness, right? What you're gonna do is you're gonna divide this plate into smaller elements, hence your W1 and W2, W3, and so on and so forth. And then you're gonna use the concept of moment to create this equation. So to show you, okay, we have this. So recall the concept of moment. When you have a resultant R and we want to take its moment about a point, we use M equals FD. And total moment is just equal to R times perpendicular distance to that point, and it's equal to summation of forces times distance. Now, if distance or perpendicular distance is hard to find, we use Varanon's theorem, separating the resultant into your X and Y components. So you have Ry times distance x equals summation of forces y times the respective distances x. And do the same thing for Rx. Now for centroids, or center of moment, instead of Ry, we're going to use weight. So total weight times distance x from a reference axis equals summation of your components for your resultant, and then for your centroid, it's your divided weights. So small w, and then the respective distances from an x-axis. And that's the same concept for your y. So x bar and y bar denotes the centroid of your object with respect to a reference axis. So for example, here, this is my reference axis, right? This is axis z. So this total weight w, x bar is its total distance from your reference axis, and then we have w1, and then x1, w2, x2, and so on and so forth. Okay, so that's basically your equation to get center of gravity or centroid. Next, centroid of area. So the point corresponding to the center of gravity of a plate of infinitesimal thickness. So infinitesimal thickness just means very, very, very small thickness. So I call this centroid instead of center of gravity because an area doesn't have weight. Remember, center of gravity relates to weight. Okay? So for area, it's just a centroid, and these are your equations. So once again, let's try to get the equations for that. So area, recall, equation for area, an equation for weight is unit weight times volume. If you remember from your physics class, okay? Unit weight times volume. If you have an object that has uniform thickness, that volume is just equal to the cross-sectional area multiplied by thickness. So V is equal to T times A. Okay? And then we're going to use that. So unit weight T times total area A. So unit weight times thickness times total area A times x bar. So distance of its centroid from the y-axis is equal to, then you're going to divide that weight into smaller parts. So unit weight is the same no matter how small your object is. Thickness is the same since it's uniform. And then instead of capital A, we have small a to denote its smaller parts. And then x, so the distance of the centroid of that smaller area from your reference axis. Unit weight and thickness cancels out, and you'll get the equation ax bar is summation of ax. So same thing for y. Okay. That's your equation. Now the expression ax bar and as well as ay bar is called moment of area. So area multiplied by distance from a reference axis. Next, since we have an area, we also have a line. So a line may be assumed to be the axis of a homogeneous slender wire. For example, here, so you have your line. The centroid of a line doesn't have to be along its body. As you can see, here's an example. It's outside the body. So that's possible as well. And again, these are your equations to get that. Again, it's stated that a line is just the axis of a slender wire. So let's draw a wire here. It has a length L, and since this is a wire, it has a cross-sectional area A. Once again, using this concept wherein weight is unit weight times volume, we can create another equation. So for a wire, its volume is just total length times its cross-sectional area. Therefore, volume is just length times area. Okay? And then using that, we can say unit weight times total length times total area times distance of the centroid of that length from a y-axis. So that's your x bar. It's equal to, then we're going to divide that line into smaller segments. So summation of unit weight times the smaller segment L. Area is constant, right? It's uniform. That's why this is still capital A. And then the individual distance of your smaller segments from your reference axis. So for area, thickness is uniform. For a line, area is uniform. And then from this, you can get this equation L x bar equals summation of your smaller lengths times x. Then we can say the same thing for y. Okay. Then we can also determine your centroid using integration. Now remember, what we've been doing so far is dividing or chopping up our weights, areas, lines into smaller pieces. Now you can divide that into very small pieces, and then we can just call that your differential dimension. So for example, so we have your total A x bar, and then instead of summation, we're using the integral because we divided it into a differential area, A, dA. So integral of x dA instead of summation of ax. Okay, so that's just the difference. We're just dealing with smaller areas. Same thing with y, and then same thing for length. Lx bar is summation of x times differential length L. So instead of summation of L times x, summation of L times x, we have integral of x dl. And then same thing for y bar. Okay, so those are your equations. Another concept we have for centroid is symmetry. So if a plane figure has a line of symmetry, its centroid is located on that line. And then if a plane figure has two lines of symmetry, the centroid is located at the point of intersection of the lines. For example, we have a triangle, right? We know what symmetry is, right? So at this line, if I draw a straight line here, this triangle is symmetrical from the left and right. Okay, that's the only line of symmetry that it has. So if I try to draw a horizontal straight line, there's no symmetry from the top and bottom. So there's only one line of symmetry here. And then your centroid can be located within this line. Okay, so that's what that means. While, for example, if you have a rectangle, it has two lines of symmetry, one along this length and another along this length. Therefore, its centroid is directly at the intersection. Okay, so that's your concepts for centroids and center of gravity. Do you have any questions so far? Please answer in the chat. About the others, please answer as well. Do you have any questions? Okay, good. Since you don't have questions, let's move on to the next slide. Your equations. So we have your basic shapes and lines, and then we have equations for their x bar and y bar, and then their equation for their area. So for example, if you have a triangle, okay, and then you have a reference axis. So for here, x bar is not included. We just have your y bar. So y bar, h over 3, this distance is based on the bottom portion of your triangle. So on its actual base. So distance of centroid from the base of a triangle is h over 3. I don't think you can see it, but I've uploaded this PDF. So you can take a closer look there. Okay, I'm just gonna go through all of these equations. Next, you have a quarter circle. Okay, x bar. So distance from the height. Okay, distance from this side is 4r over 3 pi. And then same thing, your y bar. So distance from the base of the centroid is 4r over 3 pi as well. And then the area of a quarter circle is just 1/4 pi r squared. Next, a semicircle. So you have a semicircle, right? If your reference axis is directly at the center, your axis of symmetry, x bar is just 0 because x bar is directly there. There's no distance from your referential y-axis. And then distance of your centroid from the base of your semicircle is 4r over 3 pi. And then area of a semicircle is just 1/2 pi r squared. Now, what about if we have a quarter elliptical area? So here, so x bar, which is the distance of the centroid from the height of your quarter ellipse, is 4a over 3 pi. A being the length, half the length of the major axis of your ellipse. And then the y bar, distance from the centroid to the base of your quarter ellipse, is 4b over 3 pi. And b is half a minor length of your ellipse. Okay, and then the area of a quarter ellipse is just pi ab over 4. Next, if you just have a semi-ellipse, okay, so considering your reference axis again, acting here at its line of symmetry, x bar is 0 again, because it doesn't have distance from this axis. And then y bar, distance of the centroid from the base of your semi-ellipse is 4b over 3 pi. Again, b is the half length of your minor axis. And then area of your semi-ellipse is pi ab over 2. Okay, next we have parabolas. So a semi-parabolic area we have here, okay? So distance, so x bar is the distance of your centroid from this height or from this side. And that is 3a over 8. And again, a is the distance from your half of your half of your parabola to the edge. For a, if you remember the latus rectum, that's 2a. So half of that is your a. And then y bar, distance from this point here at the bottom, that's 3h over 5. H is your height. And then for a parabola, so parabolic area, x bar again is 0 if your reference is on the center, rather here on its line of symmetry. And then y bar is 3h over 5. So same with your semi-parabola. The area of a semi-parabola is 2ah over 3. The area of a parabola is just 4ah over 3. And then we have a spandrel. So a spandrel is the area outside your parabola. So this is the equation of a parabola still, and this is your spandrel, area under it. Okay. So distance of centroid from this axis on the left is 3a over 4. And then distance of your centroid from the base is 3h over 10. Area of a spandrel is ah over 3. Now, to get the equation of a general spandrel, x bar is n plus 1 over n plus 2 times a. So n here is the degree of your parabola. So you'll talk more about this in shear and moment in beams, okay? Because this is where spandrel is used. And then y bar again is n plus 1 over 4n plus 2h. Again, n is the degree of your parabola. And then the area, general equation for the area of a spandrel is ah over n plus 1. Okay, so for example here, this is a second degree parabola. So n plus 1, that's second degree, that right? N is 2. N plus 1 is 3, so that's why this is 3a over n plus 2, 2 plus 2, so that's why this is 4. Same thing for the other equations. Now, lastly, we have your circular sector. If this is your reference line and this as well on the left, distance of your centroid from point O is 2r sine alpha over 3 alpha, where alpha is half the angle of your sector. Okay, and then r is the radius of your sector. And then if your reference axis is here on this line, so y bar is 0, and then area of a circular sector is ar squared. And then finally, we're done with areas. Let's talk about lines. So we have a semicircle and a quarter circular arc. So for the quarter arc, x bar is 2r over pi from the left side. Y bar is 2r over pi as well from the bottom. And then its length is pi r over 2. And then for a semicircular arc, if this is your axis, again at the line of symmetry, x bar is 0. And then y bar from the bottom is 2r over pi. And then length of your semicircular arc is just pi r. Then lastly, arc of a circle. So again, your reference axis is this point and this line, horizontal line. So x bar, distance of your centroid of this line from point O, is r sine alpha over alpha. Again, alpha is half the angle of your sector. Okay, and then pi bar is 0, and then length of an arc of a circle is 2 alpha r. If you remember, length of a sector from your math, that's also your S, right? S equals r theta. So that's why length, which is your S, equals r theta, theta being the total angle here. So that's why that's twice alpha. Okay, so those are your equations. Make sure to familiarize yourself with that because these are what we'll use in our succeeding problems. Now, in actual, we're not just dealing with one shape. Many of the figures used in engineering are composed of combinations of geometrical figures. If a given area can be divided into parts, each centroid of which is known, the area moment of the total area will be the sum of the moments of area of its parts. So AX bar is still summation of AX. AY bar is summation of AY. Now so this looks like our previous equation, right? However, now these A's are the elemental area, are the geometrical shapes. So before they are the elemental areas, right? Your divided segments. So now they are the areas of your geometrical shapes, ones that we are familiar with. Okay. So next we'll have examples. So before we move on to examples, do you have any questions? Please answer in the chat once more. Okay, thank you. Let's have examples. Okay, number 1. Determine the coordinates of the centroid of the area shown with respect to the given axis. So we have this total shape. The given axis is this x and y. So we want to know the coordinates with respect to the given axis. I'll show you the answer. Okay, so first of all, you're going to divide your area into familiar shapes. So can you tell me what these familiar shapes are? Correct, Marilyn and Jose Francisco. So legado and teleosis. Legado. Good. It's a triangle and a semicircle as already shown. So your triangle is what I'll call your area 1. And then this semicircle is your area 2. Okay. So first step is to get the value of those areas. So area 1, triangle, so that's 1/2 base times height. So 1/2 base, this is the base, this length. And we know that's also the diameter of your semicircle. The radius of your semicircle is 3, therefore the diameter is 6. So that's why 1/2 6, and then height is given 9. Okay. So that's 27. Area 2, your semicircle, that's just 1/2 pi r squared. So 1/2 pi, again, r is just 3 squared. The answer is 9 pi over 2. So total area is just the sum of that, 41 over 14, and store that in your calculator. Next, using this equation, ax bar equals summation of ax, you can solve for x bar. So again, a is just this. I wrote it as a variable for now. And then let's begin with our summation. So let's start with a1. So just a1 times its distance from the y-axis. That's your x, okay? X is distance from the y-axis. So your centroid of triangle is somewhere here. This is again your y-axis. So this is x1. So how do we get that? So before we continue, I'd like you to remember this, okay? Because we're going to use this a lot. if this is your triangle, this is the centroid, okay? And then this is the length that we're concerned with, right? The distance of the centroid from this height is 1/3 L. Therefore, the distance from this point is 2/3 L. Okay. Now, if we're concerned along this direction, the distance of your centroid from this length is 1/3 L. And then from this point, it's 2/3 L again. So just remember, distance of your centroid from the higher end is 1/3 length. Okay, so keep that in mind. So now that we know that, this is x1. So we're looking for distance from this end, which is the higher end, right? So that is 1/3 L along this direction. Okay, so 1/3 times 6, and 1/3 times 6. And then plus A2, and then distance from this y-axis, that's the radius, so that's just 3. Okay, so 3. Computing for x bar, you'll get 2.34. Next, let's do the same for y. So a y bar is summation of ay. So we'll begin again with a1. So y bar is the distance from your x-axis. Okay, let's start. So this is your triangle. Again, this is where the centroid is. So distance from your x-axis, this is your y bar. So again, looking at that length, that's actually the length from your point. Length from a point is 2/3 L, and L is 9. So 2/3 along this direction, again, which is 9. That's why this is 2/3 9. Okay, and then plus A2. This is the centroid of your semicircle. So you want to get its distance from this part. Okay, so from here to here, we already know that's 9. So I can just use that already. So we have 9 here. And then we'll just add this length, right? So this length, we should know already because that is in our equation. So let's check if we can. Semicircle, distance from the base, which is what we're looking for, that's your y bar. It's 4r over 3 pi. So keep that in mind, 4r over 3 pi. R is 3, so 4 times 3 over 3 pi. 4 times 3 over 3 pi. And that's it. And then just solve for y bar, you get 7.47. Final answer, since we're looking for coordinate, the x coordinate, which is 2.34, and then the y coordinate, 7.47. And that is number 1. Any questions for number 1? Please answer in the chat. Saan nanggaling yung 6 sa A6? Here? Okay. This one, right? So A1, again, A1 is your right triangle. So this is your Y1 or X. Okay, so this is your A1 again. We're looking for X, which is this length. Okay. So if you recall, that is the length from the higher end. This is your point. This is your higher end. We're looking for length along this direction. So since it's a higher end, that's 1/3. 1/3 length. So 1/3 times this length, which is again the diameter of your semicircle. Your radius is 3, so diameter is 6. That's why that's 1/3 times 6. Okay? Okay, any other questions? Okay. None, let's move on to number 2. Oh, thank you. Okay. So again, we have number 2. A slender homogeneous wire of uniform cross-section is bent into the shape shown in the figure. Determine the coordinates of the centroid. So we have this shape. So once again, we're going to divide your lengths or segments into familiar lines. So first we have your straight line. So let's call that length 1. We have this semicircular arc. Let's call that length 2. And then we have this, again, straight line. So that's your length 3. So we have L1, L2, L3 respectively. So first, length of segment 1. It's given, it's 6. Okay, so no problem there. Next, semicircular arc. We have an equation for that. It's just it's just pi r. Okay. If you forgot the equation of the length of a semicircle or semicircular arc, remember? The perimeter of a circle is 2 pi r. Perimeter of a circle is 2 pi r. This is a semicircle, so we divide that by 2. So 1/2 2 pi r. So that's just pi r. Okay, so that's just 4 pi. Since radius here is 4. Okay. And then length 3 also given 8. And then just add all of those lengths, you get 26.57, and then store that in your calculator. Next, use the equation Lx bar equals summation of Lx. Again, L is 26.57. X bar is what we're looking for. So let's start with L1. So L1, again, X is distance from the y-axis. So this is your X1. Now we have a sign convention here as well. If your segments or distances are to the left or below your reference axis, they are negative. Your length 1 is to the left of your y-axis. That's why this distance will be negative. Okay, and that distance is this length, which is also the radius of this arc, which is 4. That's why x1 is 4. And again, it's to the left, so negative 4. Next, we have your semicircular arc. Okay, so this y is directly at the axis of symmetry, right? And therefore, the centroid of your arc will also be along this line. Since that's the case, your x is 0. Okay, and then L3 here. So this is the centroid at this portion. So distance from the y-axis is this length, and that's x3. So how do we get x3? Well, first of all, we'll get this length, which we already know to be 4. So that's why here, there's 4. And then we need to get this remaining length. Now, to get that remaining length, take note, we have a right triangle if I do this. So I isolated that here. This hypotenuse is just 4, since again, this point is at the centroid, so that just divides your total length into 2 equal parts, so 4 and 4. And so 4 and 4. And then angle is given 30. I need this, which is the base of our right triangle. And we'll use trigo functions to get that. We'll use cosine. So cosine 30 equals adjacent over hypotenuse. So adjacent, which is the base, is hypotenuse times 4 cosine 30. So that's why this is just plus 4 cosine 30. Solving for that, you get 1.34. Next, let's do the same for the y bar. So Ly bar is summation of Ly. So let's start again with L1. Again, L is, y is the distance from your reference x-axis. This is the reference x-axis. Can anyone give me what is y1? Correct, it's 3. Correct, Jose and Marilyn. So Legado and Pedrosis. Again. Legado. Okay, yeah, it's 3. So hence 3. And what about L2? So L2, this is its distance from your x-axis, and that's y2. So let's see if we have an equation for the centroid of your arc from the base. So again, let's see. We do. This is your arc. Okay. So we have the same reference axis. Axis is at the base. And that is y bar. And the equation is 2r over pi. So 2r, again, our radius is 4. So 2 times 4 over pi. So let's see. Yep, 2 times 4 over pi. And then lastly, we have line 3, which is this. This is the centroid, this is your x-axis, so this is y3. Can anybody give me what's y3? Correct. Colin and Lloyd, so Sosa and Perry. It's 2. Or this is all we need, which is the height of your right triangle, right? So it's 4 sine 30, which is 2. So 4 sine 30 or 2. And then compute for y bar, you get 2.48. So our final answer is 1.34 times 2.48. Okay, so that's number 2. Any questions for number 2? Please answer in the chat. How about the others? Please answer as well. Okay, great. Since you don't have questions, let's have number 3. Okay, number 3. Locate the centroid of the shaded area shown. Okay. Shaded area. Oops. So meaning this entire thing. Yan. So first step is to divide it again into familiar shapes. So I'm most familiar with right triangle, so that is how I'll divide it by drawing a straight line here. So you have 1 right triangle, 2, and 3 right triangles. So once again, get the value of those areas. Let's start with area 1. That's 1/2 base times height. This is the base, which is 6 plus 6. So that's 12. So 1/2 12 times this height. So this total height is given to be 12. The height up to this line is 6. So the remaining height is 12 minus 6. So that's 6. So 1/2 12 times 6, you get 36. Next, A2 and A3 have the same dimension, so they'll have the same area. So 1/2 base. This is the base, which is also equal to this. So 1/2 6 times height, which is also equal to this, and that's 6. So 1/2 6 times 6, you have 18. Again, A2 and A3 are the same. They're 18. Get the total area. So A1 plus A2 plus A3, you'll get 72. Okay, now that's done. Let's use our equation. AX bar equals summation of AX. So let's start with A1. This here A1, again, X is distance from the y-axis. So this is the centroid, approximation of your centroid on the first triangle, and this is what we need. So this is the length from the higher end, right? Therefore, that's 1/3 length. And then this is your length. Therefore, 1/3, 12. So 1/3, 12. Okay? And then next, A2, right? So distance from the x-axis, the y-axis, that's your x2. And again, this is from the higher end. So we're solving for, the equation is 1/3 times length, and this is your length. So 1/3 times 6. So that's why this is 1/3 times 6. Next, area 3, this is the centroid. this is your x sub 3. From this point again to the y-axis. So can anybody give me the equation or value of x sub 3? Mm-hmm. Mm-hmm. Again. So, ito lang yung A3. Okay. Let's see who got it. Correct. Jose. Who else? And Marilyn. So correct, Teliosis, and Legado again. So you'll get 3 points. Okay. So you're correct. It's 6 plus 2/3, 6, which is 10. And nobody got it except for those two. So first of all, again, this is your only right triangle. And we already know this length. So that's 6. And then plus the remaining. This is length from a point. Therefore, that's 2/3 length. And length is 6. So 2/3 times 6. So 6 plus 2/3, 6. Okay? Which is 10. And then solving for x bar, you'll get 5. Next, y bar. So again, ay equals summation of ay. So let's start with a1. Y is distance from the x-axis. So again, this is your centroid. This is y1. So y1. So the distance is, so we already know this length. That's given to be 6. So that's why 6 first, and then plus whatever this length is. And that length is from the higher end. So that's 1/3 length. The length is along this direction, and that is 6. So 1/3 times 6. Okay. Next 2. So this is what we're looking for, right? Y2. So that is from a point, right? Distance of centroid to a point. So that's 2/3 length. And our length is this, which is 6. So 2/3, 6. Same thing with the third one. This is your y3, which is distance to a point. So that's 2/3. So 2/3 length, which is again 6. So 2/3, 6. Okay. And then solving for y bar, you get 6 inches. Okay. Any questions for number 3? Please answer in the chat. Okay, good. Let's have another method. So there's another way to solve for this. So that's method 2. So the other method is considering it as a total shape and then just subtracting the empty areas. Okay? So for example, I'm going to consider this as just a square. Okay, so this entirety is a square, and that's your area 1. As you can see, my square is area 1. And then subtracting the empty shapes, which are these orange right triangle and then this green triangle. That's your A2 and A3 respectively. Next step is the same, figuring out what's the area. So let's start with 1. That's just a square or rectangle, so base times height. Base is 12, height is also 12. So 12 times 12, 144. Next, this orange right triangle. So 1/2 base times height. 1/2 base is this, which is 12. So 1/2 12. And then this height. This height is 6 because total length is 12. And then this length is 6. So the remaining length, 12 minus 6, that's 6. So 1/2 12 times 6, 36. And then the green one. So even though it's not a right triangle, the equation is the same. 1/2 base times height. So 1/2 base, so 12, as you can see clearly. And then height, also given 6. So the answer is 36. Okay? So they're not the same, the orange and the green one, okay? They just happen to have the same dimensions or equation. So I didn't just copy this from A2, okay? Nagkataon lang. And then to get the total area, you're gonna get your total shape, which is again your square, and then subtract your empty spaces. So minus A2 minus A3, you'll get 72, which is the same as your previous answer. Okay? So that's how you deal with empty areas. Then let's answer. So remember, we had a sign convention where if distances are to the left and below your reference axis, your distance is negative. Same thing with area. If your area is empty, that is also negative. Okay, let's do that. So AX bar equals summation of AX. So let's start with A1. So A1 again is just your rectangle. And distance is just half the height. Sorry, we're starting with X bar. So X is half the base, and that is 12. So half of that is 6. So that's why distance is 6. Next, A2. This your A2. This your centroid. Distance from the y-axis, that's your X2. And that is, since it's from the point, that's 2/3 length. And length of this is 12. So that's why this will be 2/3 12. And then finally, your green one is the centroid. Distance from the y-axis is given. Already shown there, it's 6. So 6. And take note, whenever you have an empty area, instead of addition, you have subtraction. Solving for X bar, you should get 5 inches. And then same thing with Y bar. Let's start again with A1. Okay. So this is the centroid. Y is distance from the x-axis. So that's your Y1. And again, that's half the height. The total height is 12. Half of that is 6. So that's why this is 6. And then minus the orange one. So this is your centroid. This is distance from the x-axis, right? So we already know this length. Again, that's given to be 6. So it's going to be 6 plus whatever this is. And that is distance from centroid to a point. So that's 2/3 base, or rather 2/3 length. So 6 plus 2/3, 6. Okay? So you'll see 6 plus 2/3, 6. And then finally, the green one. Okay? So this is your centroid, distance to your x-axis, and that is your higher end. And distance of centroid to higher end of a triangle is 1/3 length. This is the length. So 1/3, 6. You'll see 1/3, 6. Again, empty spaces are subtraction. Solving for Y bar, you'll get 6 inches. And that is your method 2. Any questions for method 2? Please answer in the chat again. Okay, good. And then let's have the last example for today. Find the coordinates of the centroid of the shaded area shown. So you have a bit of a complicated shape. So in this case, you can't just divide it into familiar shapes. Like for example, if we do this, right? You'll say, I have a rectangle. But we don't know what this is. Okay. So you can do that. Instead, we're gonna try to imagine it as a total shape and then just subtract your empty spaces. So what I did, I imagined it to be a rectangle again. And then your empty space semicircle, area 2, your quarter circle, area 3, and then your right triangle, area 4. Okay, so those are my segments. So let's start with area 1. Again, your total rectangle, base times height. So let's first compute for the base. So this is the total base. It's not given. It's not 12. 12 is only up to this point. So I need to know the rest. And the rest, is if I draw a straight line here, you'll see that it coincides with your quarter circle. This quarter circle has a radius of 6, therefore this is 6. And then this is also 6. So total base of your rectangle is 12 plus 6, as you can see here. Next, multiply by height. Good thing height is given. It's 12. So times 12. Total answer is 216. Next, area 2. It's just a semicircle. So that's just 1/2 pi r squared. So radius is given 4. So 4 squared over 2. And that's 8 pi. Next, this is a quarter circle. So 1/4 pi r squared. R is 6. So 1/4 pi times 6 squared. So that's 9 pi. And then finally, you have this right triangle. 1/2 base times height. We already found out that this base is actually 6 since it's the same radius as your quarter circle. So 1/2 6. Now what's the height? This is the height. Total height is 12. Again, radius is 6. And that's also equal to this. This is also radius. So 12 minus 6, you'll get the height of your triangle, which is 6. That's why this 1/2 6 times 6. And you'll get 18. Okay, so those are all your areas. Next, compute for the total area. So it's A1 minus all your empty spaces. So minus A2, A3, and A4. You'll get 144.59, which again, you should store in your calculator. Okay, next. Let's start with AX bar equals summation of AX. Let's start with A1. So A1 is your total rectangle, right? And then centroid of your rectangle is here. And then distance from the y-axis is this. So this is your x1. Okay. Can anybody give me the value of x1? Correct. Kurt and Lauren, so Chua and De La Cruz. It's 9. Yeah. Correct, it's 9. Since this total length is 12 plus 6, right? So that's 18 divided by 2, since this is just a rectangle. So that's 9. Very good. Next, area 2. Okay. So let's solve for that. Area 2. So this is the centroid of your area 2. And then this is what I need, y2. Now, unfortunately, right, I can solve for this distance. That's just 12 minus 4. But then I would need this, right? Length of centroid to the top of your semicircle. Now let's check, do we have that? Let's check in our table of equations. Again, it's a semicircle. No, what we're given is from the centroid to its base. And that has the equation of 4r over 3 pi. So I can't do that. I only know this distance. So instead, I'm going to take this total length 12 and then subtract this to get the distance from centroid. Y bar na pala yun. Joke lang. So that was advanced. Scratch that. Nasa X bar pa lang tayo. Okay. So again, this is the centroid of your semicircle. Distance to the y-axis is your x. So that's x sub 2. And that's actually the radius of your semicircle, and it's equal to 4. That's why this is 4. So 9, 4. Next, area 2. Now again, this is what we need. Your x sub 3. So, like what I said earlier, we can try doing this and then getting this distance. But this distance doesn't have an equation yet. So instead, I'm going to take the total length and then subtract this length, which we know. And let's check for a quarter circle, distance from the edges are both 4r over 3 pi. So for a quarter circle, distance to both edges is 4r over 3 pi. So final equation, total length, which is again 18 minus 4r over 3 pi. And r is 6, so you'll see 18 minus 4 times 6 over 3 pi. And then finally, area 3, this is your x sub 4, right? This is your centroid. And then to get that, we can get this, that's 12, plus whatever this length is. That length is to a point, so the equation is 2/3 length. So 2/3, and this is 6. So 12 plus 2/3, 6. Yep. And so those are all our equations. Remember, again, empty spaces are subtraction. Solving for x bar, you'll get 7.74. Next, let's solve for y bar. So the equation is ay bar equals summation of ax. Let's start again with a1, your rectangle. This is the centroid of your rectangle, and then this is y1. y1 is just half the height. Total height is 12, so y1 is 6. So a1 times 6. Next, area 2. Area 2 is what I said earlier. So that's just total height minus this length, which is 4r over 3 pi as well. So you'll see that it's 12 minus 4 times 4 over 3 pi. 12 minus 4 times 4 over 3 pi. Next, let's take area 3. Okay, so we'll encounter the same problem with area 3. We don't know this length, right? What we know is length, a distance from the edges. So centroid to this edge, which is again 4r over 3 pi. So to get distance of this centroid to x-axis, we're going to take this total height, which is 12, and subtract this, which is 4r over 3 pi. So 12 minus 4r over 3 pi, and r is 6. And then finally, your right triangle, this is your y sub 4, right? That's the distance from your higher edge. So that's 1/3 length. And then this is your length, and that is 6. So 1/3 times 6. Again, empty spaces are negative. Solving for y bar, you'll get 5.07. Final answer, 7.74, 5.07 as your coordinate. And that's it for number 4. Any questions for number 4? Please answer in the chat. Okay, great. So this is number 5, which looks a bit more complicated. That has an additional concept. So I'll discuss that next meeting instead. Okay, I mean next lecture meeting. So we have 2 more equations, problems to go, number 5 and number 6. So I'll continue lecture next week, Tuesday. This Saturday, you'll have your seat work number 3. Okay, and then later today, I'll upload your IP exam number 2 for those who got a grade of 3 in your modular, a grade of I or IP for module 2. Okay, again, I'll upload the IP exam later. Same instructions apply. Unlimited attempts. So same with what I did for IP1 or IP exam 1. Okay. Do you have any questions? No more concerns, clarifications before I dismiss you? Yeah. Hindi pa yun final grade. I'll still have to add your recitation grades. I'll deploy it after I add the recitation points. So probably by 11, I'll be done with adding your plus points. And then at 11, I'll also upload your IP exam. Okay, any other concerns? Hindi. I'm only adding this. Yan. For the second module. I'm gonna get a percentage of this to add as your to add as your extra credit. Okay. All right. Can we retake the test if we didn't pass? Although our M1 grade was na po. Okay. Oh, IP exam. The only people who take the IP exam are those who got IP. So if you pass module 2, you don't need to answer that. So what test are you talking about to retake? Ma'am, can we retake the test if we didn't pass? Although our M2 grade are passed na po. Oh no. You cannot retake the modular exam. Okay. Only IP exam can be retaken for those who got a failed grade. So I or IP. You only get one chance for exams. Is there any way for us to get a higher grade aside from the recitation points? Supposed to be your quiz shows. Unfortunately, I wasn't able to give one last meeting because I got my vaccination. So there was a conflict of schedule there. So supposed to be recitation points and quiz show. Those are the ways to increase your grade. And nothing else as of now. And by the way, for those, for example, I explained this during the orientation. If you got a perfect score on your IP exam and you still failed the module, That's what it means because your score was too low that even though you passed or you perfect the IP exam, it's not enough. So that means next term, you're going to be enrolled in a completion module, which should be free. And you just have to accomplish the requirements there in your completion module next term in order to convert your grade from an I or IP to a 3. Okay? Any other concerns? You can answer the IP exam until the end of this term. So until the last Saturday of this term. Okay. Anything else? I'll end the recording there.